Everybody introduce themselves. Aaron, thank you.
Hello. Hi, everyone. So my name's Aaron. I think some of you have heard of me before from the introduction from the guys at the front. Thank you. So I am a solutions engineer at a company called Algolia. I'll introduce in more detail what Algolia is very shortly. As you can hear, I'm actually not from Toronto or Canada. I'm from London in the UK. I was the fourth employee in our London office, and I should probably explain why I'm here in Toronto. And I actually studied here 4 or 5 years ago, and I have this annual pilgrimage. I come back to Toronto every year to see my friends, and Daniel happened to reach out at Algolia. I happened to hear about it, and so one way or another, I've ended up here spending my vacation talking to you guys. But very happy about it all the same. So without further ado, let's talk about search and Algolia in more detail. This is the rough structure I have for today. I'm going to start by talking a little bit about the search landscape in general. I'm aware some people will already be knowledgeable about the likes of Solr and Elasticsearch. So I'll touch on why Algolia is different, and then I'll run through a few of these things, doc search, how we can index with Algolia, and I'm going to do some coding-ish here on the laptop. We'll build a very trivial demo throughout the course of today, and then at the end I'm going to touch on voice search and image search, okay? So just to kick off, again, I'm not going to pretend like no one has ever not used a search engine before. Most of what people have done with search today has been done using either Elasticsearch or Solr, maybe some other search engine, but those are the two I find most often. And both those engines are built on something called Lucene. And Lucene is a library for building search engines that is open source. Now, Elastic and Solr can be used for lots and lots of different things. We actually use Elasticsearch at Algolia for some log analysis in a totally separate project from the search engine itself. For the next 45 minutes or so, I want you guys to think specifically about building consumer-grade search experiences around structured data. So think about when you go on Netflix and search for something, when you go on Amazon and search through products. You might be building an app where you search through basically any content you can think of, but it's for the purpose of delivering a way for your users to find what they're looking for very, very quickly. Now, Solr and Elasticsearch, again, I mentioned they're built on Lucene. They all share the same fundamental principle of relevance. So Lucene uses something called TF-IDF for computing relevance. Okay? What that means is when the search engine tries to figure out what to show you based on what you're searching for, it uses a very mathematical approach to essentially determining what you're looking for. I'm showing you this because this is an example of what Lucene's explain command produces when you try and figure out why you're seeing maybe these particular results for a given query. I'm going to make no attempt at having you guys understand what this means. But what you can take away from this is it's not that intuitive, it's hard to reason about. And the reason Lucene works in this way is if we look at actually how TF-IDF was essentially thought up, it was originally for essentially taking documents of long text and doing search across those documents. That is a complex problem. The answer to actually figuring it out is obviously very complex as well. But when we think about building those experiences I mentioned, for example, if we search for movies on Netflix, maybe we don't need such a complex way to figure out what you're looking for. And that is one of the very core differentiators between Algolia and Lucene-based engines, as I'll show you when we look through Algolia in more detail. So when we think about what we do want from a search engine to power these kind of experiences, most people think of, right, well, we want it to be fast. I'll talk about speed in a little bit later on. We want it to be relevant. And if we're having to look at all these floating point numbers to try and figure out how relevance is working, I don't know about you guys, but I would rather just not do that. And then certainly for us as developers, we want the developer experience to be really nice, okay? So I'm going to touch on these three things later on. But if we think back to all the things we can do with Lucene-based engines, maybe this isn't such a problem for what you're trying to do, okay? So I'm not here to knock any existing technologies. That's not my job. What I'm trying to explain is Algolia was built for something quite specific, and we've built everything from scratch to deliver upon that, okay? So back in 2012, the co-founders of Algolia, two French guys called Julien and Nicolas, they've been involved in the search space since the late 90s. If I remember correctly, they worked for a French competitor to Google at the time. And they've been building search engines ever since. And in 2012, they thought they would build a new search engine from scratch, but to work on mobile devices, right? The mobile space is growing rapidly. And that means building a search engine that can run on these things. So in 2012, this is the iPhone 4S on the left, the Samsung Galaxy S2 to the right. And as they were building their new search engine, they first built it in Java to run on Android. And they were testing with a data set of about 250,000 search records. And they were getting query processing times of like 700 milliseconds or so. Not that great if you're trying to search through things very quickly on your mobile device. We aim for less than 100 milliseconds round trip if you want a true search as you type experience. They then rebuilt the engine for iOS in Objective-C. Similar problems there, and they came to the conclusion that to get the performance they were looking for delivering these great search experiences on mobile devices, they were going to need to rebuild the engine from scratch in C++. So from day one of Algolia, building a search engine that was really, really fast was really priority number one. And again, it was to run on these kinds of devices. In 2013, they came up with this smart idea of taking that search engine that they had built from scratch to run on these mobile devices and put it in the cloud. Because the problem with what they had built to date is as soon as you want to provide search over maybe data that's changing server-side or any kind of networked application, it becomes not as useful. So in 2013, they deployed the search engine into the cloud, and in doing so took a somewhat strange decision by today's standards, which is to do so on their own bare metal infrastructure. So Algolia, even today, is not powered on the likes of AWS or GCP or any public cloud provider. We still today maintain our own bare metal network worldwide. This is roughly what the network looks like today. And when we talk about building things from scratch, trying to get the fastest engine possible, when you put it in the cloud, we have a few different concerns that you don't have on the mobile device. Namely, you now have to optimize for high availability. So that required changing the engine again. And on our bare metal infrastructure, if you sign up to Algolia today on a community plan and you put some data into Algolia, that's actually being replicated across 3 different machines and at least 2 different data centers in order to provide high availability. So that's another concern that we've taken very seriously, and we use a master-master pattern to replicate your indexes across 3 machines at once. This is what the bare metal network looks like today. We obviously have a region in Canada. And one of the other slightly unique things about Algolia as well is that as a completely managed search engine, we can also replicate your search indexes worldwide. So if you have a 3-machine cluster based in, for example, EU West, which covers Paris and Netherlands, Paris and Amsterdam. You can then go ahead and tell Algolia to replicate one of your search indexes, say US West, maybe in Australia, and users in those regions will automatically be directed to their local node. So the infrastructure, again, we've built that from scratch, and we've also built our own search engine from scratch. That's very core to what we're doing. I like to tell a slightly anecdotal story when we talk about building things from scratch, particularly the bare metal network. In 2015, our director of infrastructure, a guy called Adam, came across an interesting failure pattern we were seeing more and more often, which was solid-state drives essentially spontaneously failing after a certain number of read and writes. That wasn't so much of a problem for us because I've already mentioned we have a 3-machine cluster. If one of them drops out, the other 2 continue to function at all times. No issue for the customer. It was an issue for us, though, having to continue to replace these machines. It turned out to be a bug in the Linux kernel. We actually worked with Samsung to find a fix. And the screenshot I have here is actually the patch in the Linux kernel that was authored by Samsung. Adam does a much better job of telling this story because he can talk about how they were waking him up in the early hours of the morning calling from South Korea. You can go and find this yourself online. It's publicly available. But again, the story here is how far we have gone to create the service that I'm going to show you today. So we've taken this to a very, very granular level. So today, a few stats from the network. This was in mid-2018, so these have changed quite a lot as of today, but you can see there, I think we might be above 60 billion searches a month now, 160 billion API calls. So the network's grown a lot since those infant years in 2013. Now, in building a search engine and putting it in the cloud, we obviously need to start building the tooling around that. So in Algolia, we've got API clients in 10 different languages. These are all open source and on GitHub. We've also created framework integrations that are also open source for the likes of Rails and Django, as well as Instant Search, which is a set of libraries for the front end. I'll talk more about those later on when we actually look at an implementation. So to summarize, we've built this search engine. We're going to walk through it today. There's really 2 key priorities that I've already outlined. One is to deliver an amazing user experience to your users when they're searching through data and trying to find what they want. The second is make it as easy as possible to integrate into your website and apps. So those 2 concerns are really paramount to everything we do. A quick overview of the company, just to give you guys an idea of where we're at. I joined last February. I was the 4th person in London, as I mentioned. We were about 180 people at the time. We're now over 320, set to be over 450 by the end of the year. And we raised our Series B 18 months ago, I believe. Just a few more numbers, over 7,000 customers. I think it's over 60 billion searches a month now. To be fair, these slides are impossible to keep up to date. And as I was saying to Daniel earlier on, we came through YC in 2014. So again, started on a mobile device, started to pivot towards cloud, came through YC, and it was really after, sort of into 2015, where the growth came. So I don't like speaking to people forever about slides and so on, so I want to get straight into the meat and bones of what we're talking about. And I'm going to start just by loading up React's website. I'm going to go to the search bar, and I'm going to start searching through their documentation, okay? You're going to see from the very first keystroke, we're getting search results back. I'm going to build out the query. Maybe I'm going to make a typo. It doesn't matter. And there we get search results. Behind the scenes, what's going on here is this is just a JavaScript component on the web page. And with every single keystroke, we're sending a network request to Algolia, searching the search index, and returning results and rendering them on the page. And we aim to have that done in certainly under 100 milliseconds. I think if I open up the developer console here, and I start searching again, you'll see those in network requests being made, and you'll see they're coming back in 20 to 30 milliseconds. Okay? So we're going straight to Algolia from the website. We're not going through anyone else's backend. Now, before we go into any more demos or the dashboard, I actually want to talk a little bit about why we're even powering React's search through their documentations. And the reason for that is through a program we have called DocSearch. So this is an entirely free thing we provide to the open source community, whereby we crawl your documentation, we index that data into Algolia, and then we provide you with the widgets to put that on the documentation's website, okay? So this has been pretty popular in the developer community. You've already seen it on React, how it looks. Just another overview here. And this has become fairly popular. Serverless are obviously one user of DocSearch. You'll probably see a lot of logos here that are familiar. The likes of Golang, Laravel, Electron, React, you name it. And if you want to use DocSearch, here's the URL. It's entirely free. Feel free to go ahead. So let's get stuck in. I have to hold the microphone, which I didn't think about, but we'll do the best we can at going through a demo. Now, what I'm going to do for the sake of today... Oh, no, it's fine. I mean, I'm not going to do that much typing because I just built it all beforehand like any good presenter. But if I have any problems, I'll just have someone hold the mic in front of my face and see how we get on there. So let's start by just diving very quickly into the dashboard, which I have in front of me. The dashboard is really just something we have built on top of our own API. So more or less anything we do through this dashboard can also be done through the API. By that I mean creating indexes, applying settings, tearing down indexes. We can create API keys that only have access to certain indexes and so on and so forth. And I've got just an empty account here with no data in it. And what we're going to do is we're going to get some data into Algolia. We're going to see how we can configure a search index to work in however way we want. And then we're going to build, or at least show you, a search UI on top of that. I'm also going to touch on a feature of Algolia that is my favorite feature of Algolia. Not many people know about it, but it's a concept called secured API keys. So I'm going to talk you through that shortly. So again, I'm using REPL and Code Sandbox here for the focus of today's session. And I'm using Node.js because as a serverless event, I thought pretty much everywhere here is using Node. Now you'll see here, 15 lines of code, nothing too crazy. All I'm going to do is ping a gist that I created yesterday with some contacts data. It's not a lot of data. It's only 500 search records. I thought I'd highlight this. We have customers on Algolia that search through hundreds of millions of search records. The fact I'm searching through 500 is just for the sake of brevity of today's session. So you'll see here, nothing too crazy going on. I'm bringing in the Algolia API client. We're initializing an index, and then I'm fetching the JSON from GitHub, and then essentially just adding those objects to the index, okay? Nothing too crazy. I'm going to run this, and if the demo gods are with us, we'll send some JSON to Algolia. Or it won't work. The laptop's making a lot of noise. I don't know if that's anything to do with it. But either way. Does anyone use REPL? No? Okay, here we go. Yeah. So this will just take a second to install the packages, index the content, and away we go. If I refresh the Algolia dashboard, we're going to see an index that is populated with those records. So there we have it, okay? So just to summarize, an index in Algolia's world is just one silo of content, okay? Somewhat synonymous to a database table. And if I click on the contacts index, you can see the data we have in here is just JSON, okay? So this can take whatever structure you want. You can imagine my trivial contacts demo uses a very different JSON schema to any of our DocSearch projects, which takes a very different JSON schema to any kind of e-commerce client. And you'll see here, for every JSON record, we've got things like the first name, the last name, the company, and so on and so forth. Now, from within the index, we can start searching straight away. So if I start searching, again, with every request, we're going to Algolia, bringing the results back. You'll see the computation times are 1 millisecond. This is a small data set, but that is quite common with most customers. And one of the very unique things about Algolia that I touched on already today is the fact that when we perform a search in Algolia, we can understand why we're seeing any particular contact in the first position, for example. And that all comes down to this trophy icon here in the dashboard. So Algolia is very unique in the sense that we don't take that TF-IDF approach to relevancy, we use tie breaking. And the way that works is we'll look through these rules one by one to try and figure out which result is most relevant for any given query. Now, Algolia comes with textual relevance out of the box, so typo tolerancy, things like handling plurals are all done for you, right? We can make some typos right here, and I've only just made this index, and everything's going to work, okay? Nothing too crazy. And if we look at the trophy icon, you'll see what Algolia is telling us. Well, we have one typo in this instance. We match in one word. We have 0 matching filters and so on. So what Algolia does behind the scenes is we'll look at, say, 2 search records. If you've got one with 0 typos and one with 1 typo, the one with 0 typos will be on top. Most commonly, you'll have 2 or more search records that both have 1 typo. So we'll look at the next rule down, right? So we'll look at, okay, well, how many words match? If they both have the same number of matching words, then we look at the next rule down and so on. And this continues until we get to custom ranking there on the bottom. And this is where you guys can include your own metrics to determine relevancy. So again, when we think about if you're building a Netflix, what you consider to be relevant is very different from what Amazon consider to be relevant, which is very different to anything you guys are building. Now you'll see in the JSON, I've actually got a number of followers for each contact. So I'm going to actually tell Algolia to use that to determine relevancy, right? Maybe a higher number of followers is more relevant than any contact with less followers. Now, by default, Algolia is searching through all of our JSON fields. So when we perform a search, we're looking through the first name, the last name, the company, and so on. The first thing we often want to do with Algolia is tell Algolia, which of those attributes do we want to search through? Pretty straightforward. Again, we can do all this through the API. I'm going to do it through the dashboard. So I'm going to tell Algolia, right, well, maybe we want to search through the first name. Maybe I want to search through the last name, and so forth. I'm going to leave it there for now. And then the second tab down here is that ranking formula. So we've told Algolia what to search through. Now I want to tell Algolia how to determine relevancy. So again, we have that default ranking formula there. You'll see we have the typo, the words, the filters. We also have geo, and I'm not touching on this today, but a good to know is the fact that we can do geo search out of the box with Algolia. If anyone wants, I can show a demo of that at the end. And as mentioned, I'm going to use that number of followers to determine relevancy in my particular search index. So I'm going to add that there. In descending order, I'm going to hit save. When we go back to the Browse tab, straight away when we start searching, we're only searching through the first name and the last name fields, and we're actually going to use that figure in relevancy, okay? So here you'll see I've searched JO. You'll see we have 2 records here that both have a first name that starts with JO. We can look over the trophy icon, and Algolia is going to tell us, it has 0 typos, 1 matching word, and so on. And in this example, you'll see the record above has a higher number of followers to the record below. So you'll see here, the record below has only 8,400 followers compared to the record above. Okay? So complete transparency and ownership over ranking and relevancy. So I always say there's 3 steps to implementing Algolia. One is telling Algolia what data we need to search through. So we've already done that today. The second step is starting to tell Algolia how to behave, and we've already done some of that today. I'm going to take one more step, and I'm going to tell Algolia to use some of these attributes as facets. So I'm going to bypass a lot of the settings here. It gets quite granular. Some people sometimes think, well, Algolia is just an API. You don't have much control over it. we actually expose a lot of the engine's behavior here in the dashboard and through the API. And faceting, just for those who maybe aren't as familiar in the search world, is a way of essentially aggregating the results for a particular search and displaying on the left-hand side, or in the left-hand side of my dashboard, how many, for example, contacts belong to a particular city or county. So again, I'm going to hit save, go back to the Browse tab, and then we've got facets, right? I can even go a little bit further here and actually make those facets searchable. So maybe we want to search through only users that are in a particular county or city. I'm going to hit save. Again, go back, and you'll see there's a search icon next to each of these facets. So we can drill down the results to maybe all contacts who are in Honolulu, but I can even search among this to say, okay, well, I want all in San Fran. Again, it's the exact same very fast touch-as-you-type experience. It's typo-tolerant and everything else, and it will only show contacts that are in San Francisco. Note, I've included in the JSON here a created by user ID field. I'm pretending in this instance that each of these contacts is being pushed by one of two users. Let's say me and Daniel. But we don't want to search through each other's contacts, right? That's quite a fundamental flaw in our application. And this is where we can use Algolia to do one of two things. The first is for every single user on our platform, we programmatically create an index for that user when the user is created, fill it with their content, configure it, and so on. And that means we have a whole lot of indexes in Algolia if we have thousands of users. Kind of disgusting. Or what we could do is have one index, push all those records into that index, and then for every user on our site, we can actually give them an API key that has permissions encrypted into it. And I'm going to show you how we do that shortly. The other thing with if we had multiple indexes, not only would it be disgusting, it would also be not that great for performance, because Algolia can build one index far more efficiently, one big index far more efficiently than if we have thousands of index that we're all trying to update very frequently. So again, I've got another REPL here. Oh, one more step. I'm just going to tell Algolia to use that created by ID field, created by user ID, as a facet, a filter-only facet, and that just gives us the ability to filter down users by the user that created the contact. Okay. So again, another REPL here, only 7 lines of code this time. So again, we initialize the client, we plug in our app ID and our API key here. And what we can now do is generate an API key, but with certain filters or settings applied. So I'm going to run that, and Algolia is actually going to give us our own API key. And if we search the index with that API key, we'll only return contacts that have a created by user ID of 1. And if you examine the front end of your website, the user's just going to see this key. It's not going to mean anything. They can't tamper with it. So we've got the data into Algolia. We've configured the indexes. We've even created an API key. The next step is to actually build out the front end on our website. So I mentioned already on the React example that we're using a front-end implementation, and that means querying Algolia straight from the website's front end to maximize the speed of request, okay? Now at this point, I should introduce Instant Search, and I mentioned this earlier on. It's essentially a library of building blocks that you can use to build out search front ends very, very quickly. So again, these are open source. We have Instant Search available in Vanilla.js, as well as React, Vue, Angular, React Native, and Android and iOS native as well. And these building blocks just make our lives easier as developers. So if everyone can just about see the screen, again, you'll see I have my app ID and my API key plugged in here when we initialize Instant Search. And then I can add widgets to the page. So Algolia gives us widgets for things like hits, and we can provide our own DOM rendering essentially on top of all this. We can provide a search box, a stats widget, and I'll show you all this shortly, a refinement list for the filtering, pagination, and so on. Now, all I've done here is plug in our index to the Algolia app I created earlier. So I'm going to take my API key, my search key. I only created this app today, so feel free to steal my credentials. And I'm going to plug that in. Now, everything being well, and I did test this earlier on, we'll get a working search front end, or we might not. Okay, everyone see? Of course, we might not end up with anything working if I didn't spend enough time building my demo earlier on. So we've got the city configured as a facet. I'll try and debug this live in a session. If we can't, I can always move to some other demos. So we go into the console. Do you have many people come to your meetup and debug demos live on stage is a regular thing? Huh? So it's coming from the hit widget. And we should be able to, oh, there we go. I started writing something, and then I'm sure Dylan handed me a beer earlier on, and then I stopped writing it. So fingers crossed, that might fix our issue, or it might not. No, it's not going to fix it. That should be fine, because it's just a string template. Again, we have plenty more demos to look at later on, so not the end of the world if we can't get this working. Expected, that's just a lint warning. That should be fine. Okay, so maybe we'll just move on to other demos. So what we'll do is we'll pretend that I created this amazing user experience on your front end. I'll see if we can fix this later on and we'll come back to it. Yeah, sure. Yeah. But the gist here is we're plugged into the front end, we query Algolia, just like we did on React.js, we get our results, and then we can display that on the page. In this code sandbox, all it is JavaScript, HTML, CSS. We don't actually have to use these building blocks to build a search experience on Algolia. We can just use the API client. Instant search is essentially something we've built ourselves on top of the API client. So again, we're really focusing on the developer experience. So we'll come back to that. I wanted to touch very quickly on to a real-world architecture, because a lot of what I've done so far has been fairly trivial and hypothetical. One of the customers I've been working closely with recently are WWF, so the World Wildlife Fund. And they are quite big on serverless, at least as a concept. And they've essentially done more or less what we've done here. So really no different, but it is in production. The important bit here being on the right-hand side, where they're monitoring a number of different APIs for new contents. They use Lambda as a cron to pull that content in from the different APIs. They send that to S3, and then they have another Lambda function which monitors, which is triggered by the creation of different S3 files, and then they send that to Algolia. So ultimately, still just using the API clients, still just sending JSON, but they're delivering a search experience to employees at WWF. So when we look a little bit further to the future, that's great that we can provide these great search experiences that are fast and relevant, but more and more folks are coming to us and saying, well, what if I want to plug Algolia into an Alexa? Or what if I want to take a picture of something and then search on stuff based on that image, right? These are all concepts of search, but maybe not how we thought about search originally. So demo time again. I'll explain how this works in a moment, but that is something we're doing on Algolia today. Now, we tried this beforehand. We'll try it now. Cheap cases. So again, what we're doing here, we're using the browser API to take our speech, turn it to text, and then we're taking that text, putting it through Algolia, getting the results back, and showing it on the page. What we can do here that's nice is use a feature of Algolia called query rules to pick up on when people search with particular words or terminology. So you'll see here we're saying, right, well, cheap cases. What does cheap mean? And do we want to search with the word cheap? Probably not, unless folks are actually advertising on their website cheap stuff. So what we can do here with the rules is say, right, well, if anyone searches for cheap, let's remove that word from the search query. We don't want to search any textual relevance with the word cheap. We'll just search for cases, but then we'll filter the results with just some numeric filters through our data implicitly. So we search for cheap cases, and all the products that are coming back are actually less than 20 euros in this case, right? So that's how we actually have Weight Watchers in the US have gone live with us on Alexa, and they're actually using this exact same mechanism to deliver search through voice. Another example that we've built in-house, which is Spencer & Williams. So the concept here is just of a bookshop or something similar. Books by Stephen King. It's a little bit slow, this one. But again, same concept, right? The interesting thing here is we can actually use those rules to pick up on when someone searches for an author. We've already set up author as a facet, so we know what an author looks like. And then we can activate a rule when someone searches for books by. We want to remove those words. But we can also automatically filter the result based on a presence of an author without actually having to configure this for every single author. So that in a nutshell is how we're doing voice search on Algolia. Very much an up-and-coming thing. I have more people ask me about voice search than actually doing voice search today. If you're doing anything related, feel free to ping me afterwards. I have another very short demo here, which is on image search. And this is actually something we built internally at Algolia in our Paris office. So it's my colleague's video. And what we actually did here is say, well, we have one of our colleagues on the front desk that takes packages every single day, has to look at the address, message someone, you have a package here, come pick it up, over and over and over again. And when we have over 100 employees in that office, it becomes pretty tiresome. So we're using Algolia in an app, essentially take a picture of the label, and we can extract the text, run it through Algolia, and with some specific settings to the engine to say, for example, consider every single word in the query optional. We can also use a rule to say, to pick up on when any employee's name has been entered, and then essentially use the first result from the engine to say, this is the employee who this package is for, and then automatically notify them on Slack. So a quick example of this at work, you can see the name Alex Webb, that's my colleague. It comes up straight away, and that's all built on top of Algolia. So again, different engine settings, very different use case, but it's still the API behind the scenes. So that is the bulk of what I wanted to talk about today, minus a slightly unfinished demo. But yeah, any questions, let me know.
So earlier you showed us using that generated API.
Yeah.
So it sounds like Algolia has been engineered to have like the browser contact their servers directly, not to go through your own backend. But what if you wanted to restrict what the users would be searching for based on ownership of document, like you showed us, and like they can't see it from the front end? Is there a way of having the browser not be able to access?
So ultimately, Algolia is an API. There is absolutely no restriction on where you search from, right? Whether it is the server using the Golang API, whether it's Alexa. We have customers use Algolia on set-top TV boxes. Or, of course, direct from an app front end or a web front end. There is implicitly, no restriction at all. The reason why we recommend a front end implementation is yes. Although, yeah, you're right. Although most people end up saying, well, if my website's down, then it doesn't matter that Algolia's down. So yes, fault tolerance, but also the developer experience, right? You don't have to build your own routes, but also because it's so much faster, right? Again, we've built everything from scratch to deliver these 50 millisecond or less round trip response times. If you put your own backend in the way, that's just going to slow things down. So there may be certain use cases where you want to do that, but the secured keys are pretty powerful. So
just to expand on that quickly, if I had a use case where I wanted to protect the data, I would have to put my own backend behind it and accept the trade-offs, which is that it would be slower, right?
So when you say protect the data?
Yep, so if you're, like, say the user wants to search through something and it's important that only that user can see their documents.
Yeah.
Like I would have to use my own system of authentication or something, right?
So, no, so that's what we did here with the secured API keys. So we generate a key that is locked down to only certain content in an index.
So what would happen if that search was performed without that key?
So if they had access to your admin API key, for example, of course they could access all the data in there. The same would be true if they had access to your GitHub profile, for example. That's just the importance of actually locking down those keys. So the conventional flow for that would be server-side, when you create the user, generate the key, store that in your database, and then only use that on the front end, retrieved from your database. Does that make sense?
Kind of, but I don't want to use it for time.
Yeah, feel free.
Admittedly, I've used Algolia a good bit in the past, so that's why I could probably explain to him as well later on. But one of the questions I had, so with my own project I was using Algolia in the past. My question actually has to do with whether or not, like this was probably like 4 years ago that I was actually using it. But have you implemented anything like percolate queries? Because I basically ended up having to go to like ES directly to implement, where you could basically do like safe search implementation, where you could basically store queries and then when things are indexed, generate actions. Can you do anything like that with Algolia yet?
So yes, we have customers doing safe search on Algolia. Yes. Okay. Probably worth talking afterwards about the implementation specifics, but certainly
so
no.
That is something now that you guys are running with. Okay.
Yeah. Okay. I didn't work here 4 years ago, so things have changed a lot, but happy to talk about that in detail. Cool.
From the security perspective of it, how compatible is it with an encrypted database, for instance? If I encrypt my database, how do I integrate Algolia to be able to decrypt it and then pull up the data that I want?
So we do have encryption at rest available for enterprises. In that instance, we actually provision dedicated infrastructure, so there's no multi-tenancy, and then we'll provide encryption at rest at the disk level. When we're responding to queries, we store the data in memory, right? That's how we're able to do it so quickly. We have no way of encrypting the data in memory and then sort of decrypting it at query time, or searching through the actual encrypted data itself. Those are just trade-offs that come with delivering super fast search. I've worked with a number of large enterprises who are notably stringent on security requirements. I haven't yet had this be a blocker. We have all the sort of certifications as well, SOC 2, Type 2, and Type 3, that come with the whole sort of infrastructure management side of things and so on. I don't know if that is useful at all.
It depends on the use case too for that one. The other question,
Yeah, well, more than happy to talk afterwards, sure.
Hi, great talk, thanks for that. I wanted to ask about searching for documents.
Yeah.
Do you expect to provide to Algolia already prepared documents as JSON, or can I just dump at Algolia any PDF or docx documents and you will search through them?
So no, you need to extract that data, send it to Algolia. We do have some techniques for better handling longer documents. We do have customers, actually WWF is one who does that today. So yeah, no limitation, but you do need to serialize it to JSON in some format. We do technically have a side service that is a crawler. So for customers who don't have the ability to, for some reason, access their data through an API, we can crawl web pages as well as PDFs and Word documents, extract that content, and then push it to Algolia as well. But for a lot of folks, extracting it on their own side and then sending it to Algolia is the easiest route.
Is it compatible with external databases? Like, can I use my own database server for this?
So absolutely. We always recommend every single customer has their own persistent data store outside Algolia. We are a search engine, we're not a database, so we have very different priorities. We're not ACID compliant, for example. So yes, but conventionally, customers will hook into something like an ORM, so that when every record is saved, they'll then send it to Algolia. So it's essentially duplicating information in the Algolia search indexes and using that for search. So you'll still have your own database.
I see. That's where that encryption that you talked about in memory comes in, because it only applies on your infrastructure, not my infrastructure.
Yeah. So whatever's going on your infrastructure is entirely your own concern. All I can talk about is how we manage our infrastructure and our data.
Thanks.
One more question about security. Is there any way to, for Algolia not to know what I store in your search indexes?
So when you say not know what you store,
I mean, is there a way of creating the index on client side and provide and send back encrypted index to Algolia, and when the search happens, it creates like some sort of fingerprint that I send to Algolia, and Algolia matches the
no, we don't do anything like that today. No. How so? So we're not a database. The cluster operates in a three-machine cluster, like I mentioned, and they use a consensus-based approach for determining what your indices look like. So if you look at our SLAs for businesses and enterprises, we go to 99.999% available search uptime, and we do that by having those three machines. And the idea there is that you can essentially destroy one of those, and we have retry logic in all of our API clients that will automatically, very quickly ping a second machine in the cluster. We have multiple layers, multiple DNS providers as well. So we have redundancy throughout the stack, and essentially our way out of deciding what the complete search index looks like is based on the consensus of two of those machines in the three. So if one goes offline for a temporary period, again, that will catch up to the index state of the other two machines. Yeah.
You still have it, right? It's not encrypted, so things happen. It could get corrupted.
Sorry? So we have firewall available with our enterprise offering, yeah.
So if, for instance, anything happens and then the data gets encrypted in memory, gets corrupted in memory,
yeah.
How do I, as a client, know that that data has been, how should I put it, has integrity, based off what hashes, based off what security measures? How do I know that it's intact?
So multiple approaches. One is we recommend all customers resync their data periodically. Okay, so if there is a problem with one of the indexes, we expect that to recover naturally. We recommend people reindex their data periodically because we have a concept called drift, and I'm not an expert on distributed systems, but the concept there is that essentially while these three indexes are constantly talking to each other and staying up to sync, it's possible that you can have essentially an indexing job overwritten at some point. It's very unlikely. I've never had a customer come to me and say that's happened, but we recommend as a best practice constantly reindexing that. When it comes to integrity, again, we're providing a search engine. The priorities we have are providing super fast search and for it to be always available. To be able to do that, we cannot also provide you the integrity around atomic transactions around your data. That's for the data persistence in the database, right? So really a differing in priorities and concerns.
Hi. So are there, you say Algolia supports super fast searching.
Yep.
And I know, and you say it's also not a database, and so the data in there is quite relatively short-lived, really. Are there performance implications about reindexing data or very volatile data? Like, is it slower to reindex or anything like that?
So just to clarify, the question is, how do we perform when it comes to indexing data?
Yeah.
Yeah, okay. So a good customer, as an example here, is Twitch TV. So Twitch TV are a customer of ours, and they index, it's like over 1 billion hours of video content, or at least just the records that represent each video. Because they've got constantly videos coming on and offline, they create an enormous amount of indexing operations. when we built our search engine, built in C++, performance was really priority number one. Indexing is part of that as well as the search time, response times. So Twitch came to us from Solr. They were having, I think, 20-minute build times to rebuild their index on Solr. Came to Algolia, got that down to 20 seconds.
Wow.
So we aim to be really, really fast at both. But even then, there is a slight trade-off in our approach, right? Because we want to make the search as fast as possible at query time. That means doing more work at index time. And so we have a slightly different approach to, for example, sorted indexes. We have a concept called replicas. More than happy to talk about that later on.
That's cool. Can we, on the same topic, like stories from the trenches, like what I've seen people out of the box just think, let's use spin Elasticsearch cluster. So when would you not recommend people to do that, but to think about Algolia instead? What you've seen, people burned by.
So number one, it depends what you're building, right? If you're building some accountancy application where you want to perform aggregations over vast data sets, we don't do aggregations like that, right? That's not a part of building these immersive search experiences we talk about. That's something where you would want to use something like Elasticsearch. If you want to provide user-facing search across that structured data, and you want to do so very, very quickly, Algolia is a perfect fit, in my eyes, as a developer. There's not really too much of the way in other scenarios I would recommend doing something differently, right? Right tool for the job.
Any other questions?
There's no aggregations at all, other than the count.
So you have the Facet Counts. We do have a feature called Distinct, which is where you might have 10 search records that all represent maybe one piece of content. Maybe it's 10 search records that are actually different sections of one very long article, for example. And we can use Distinct to only ever return one of those, right? Which makes sense. I've seen e-commerce customers use that for variations of products. I've had some people use that as aggregation. I don't call it aggregation. But we don't do aggregation in the sense of show me the sum of price across these 100,000 records. Yeah, for sure.
Cool. Cool. So let's do the draw. Thank you so much for doing this.
No worries. Thank you for having me.
So maybe you can stop the recording and I'll see who's going to be lucky winner. Everybody has a ticket? If you don't have a ticket, tell me.